I wanted to review the free response questions with you. These are questions 1, 2, and 3. And as you know, these questions are calculator active. And so I'm going to walk you through how to do the problems. I'm going to talk you through my work. And if you need help, I will also try to show you how to use the calculator to work with some of these problems. In the first problem, it's always important for every problem to read the given information. And in this function, you have a mystery function g. And it's always important to understand that it's only defined for x is greater than 0. Sometimes we tend to overlook that piece of the given. We know that when x is 1, y is 2, they give us the first derivative function, and they give us the second derivative function. So all of these things are given information. So in part A, they ask us to find all values of x. Now again, this interval is very important. That's going to be helping me to set up my calculator window. And I want to know when the graph has horizontal tangent. Now if you look at my answer down here in part 1A, I know that horizontal tangent implies that there is a slope of 0. So I'm going to take the derivative that they've already given me, which is g prime of x. I'm going to put that in my calculator as y number 1, and I'm going to put 0 as y number 2. Now when I go into the calculator, as you can see, I've already told you right here what I'm doing. When I go into the calculator, I'm going to first of all, because this is involving trig, I'm going to start with a zoom 7 window. And then after I do the zoom 7 window, I'm going to change the window, the x minimum to be 0.12 and the x maximum to be 1, so that I'm only looking for the region that they've given me. So I'm going to pull up my calculator. Now take a look at my calculator. I have y1 typed in, and I have y2 equal to 0, and I have y number 3 typed in as the second derivative. Notice also how I have the parentheses around the 1 over x and around the 1 over x squared. That's very important. Where you place your parentheses is going to make a difference. Also notice that I have y number 3 turned off right now because I'm not using the second derivative. So I'm going to start with a zoom 7, which is my normal trig window. And then I'm going to change the window to have an x minimum of 0.12 to 1, and I'm going to count by 0.1. You can count however you wish. And then I'm going to take a look at the graph. And so I can clearly see that there are 2 points of intersection where the first derivative is equal to 0. And I'm going to use my calculator by doing a second calc, number 5, enter, 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 and it will find the point of intersection that it's closest to always. And that's how I got my answers. Let's see if I can minimize that. Okay. And so that's how I got my answers of 0.064 and 0.359 just by using the calculator. Letter B, we're talking about concavity. So now I want to know when the graph is concave down. So you can see from my work, I remember that a function is concave down whenever the second derivative is negative. So I'm going to go back to my graphing calculator. And so I have my second derivative already in my calculator, and I have the y equals 0 function turned on. So I'm going to go back, and I'm just going to hit graph because I'm going to look at the same window because it's asking me over the same interval of time. And you can see that the function, or the second derivative, is negative starting at 0.12, and I need to find that point of intersection. So I'm going to do a second calc 5, again enter, enter, enter. And when I do, I will see that that second derivative crosses the x-axis at 0.233. Notice that I have my reason. I justified my answer. The second derivative is negative or less than 0 on that region, so I have my concave down interval. All right, looking at part C. Now part C starts out, it's not a really difficult question, but there is a part of it that gets a little bit challenging. So they're asking me to write the equation of a line tangent to the curve of the graph at x equal to 0.3. Well, that's really not that scary. I start out by writing my equation of a line in point slope form. I know that I need to find the slope, and they've already given me the derivative. So from my calculator, where I already have g prime of x typed in, I'm going to let the calculator tell me that the derivative, or the slope, or the y value on g prime is negative 0.472, which is the slope of my line. And so I substituted that in place of m. So that was easy. I also know that the x value is 0.3 because that was given. Now the challenge part for you, because we have not done tons of this yet, but I really want you to listen to what I'm about to explain to you and remember it the next time you need it. They told us from the beginning that g of 1 is already a y value of 2. That was given information, and so now that's when that's going to come back to play. If I want to know the y value of g at 0.3, I'm going to use an integral, because notice I have g prime of x and I'm looking for g, so I need to go backwards by anti-differentiation. The 2 is the y value that I currently have when x is 1. So I'm starting out with the 2, and then I'm going to find the antiderivative using my calculator, starting at 1 and going back to 0.3. Now the reason I'm doing that is because I already know what the y value is at 1, and then I need to collect more area by going from 1 back to 0.3. And the calculator can do all that calculation for you, and you don't need to worry about changing the signs or anything like that, because the calculator will already do that for you. So on my calculator, I would literally type, in this case it would be 2 plus, so on my calculator I would have 2 plus, and then I would go math number 9, so it would bring in my integral, or it would say f int, and I would type in y1, which is where g prime of x is, in terms of x, from 1 to 0.3, enter, and then it would tell me that the y value, or the value that I'm looking for, is 1.546. Now you may want to watch this part of the video again and really take your time to think about what I just talked about. Now this is going to become more clear as we continue on in this unit, but this is a concept that you will use over again, and now I have the y value and I can put it into my equation. So really part C is the most challenging part of this question, and part D is really not that challenging. Does the line, and even if, think about the AP test, even if you could not do part C, if you couldn't find the equation of the line, you still could do part D, because the question is, does the line tangent to the graph of G lie above or below? And we know how to do that because we know that the concavity will give that away to me. So what we know is the concavity at 0.3. Concavity we know is found using the second derivative. So using my calculator, I'm going to go to the second derivative function that I already have on the calculator, and I'm going to make the calculator tell me what the value is, the output is, when x is 0.3. And that output is 8.913, which is a positive value. Therefore, g of x is concave up, and the tangent line has to be below. So hopefully you find this problem helpful, and I'm going to break this up into, instead of one video with all 3 questions, I'm going to make it 3 different videos. So we'll pick up in the next video for problem number 2.